Hello friends and welcome to EduPediaWorld.com, your destination to online education. Friends, in all the continuing sessions, we are discussing about the characteristics of element, where we are discussing the variation of these characteristics with respect to groups and periods in the modern periodic table. So far in the discussion, we are covered with valence electrons, valency, size of atoms, metallic character, chemical reactivity, nature of oxides, gradation of physical properties, ionization energy, and electron affinity. If you want to refer to all these topics, please refer to the respective videos. So today we shall learn and discuss about the electronegativity, the concept and the variation of electronegativity of an element with respect to groups and periods in the modern periodic table. So friends, let's start with the electronegativity. Well, what is electronegativity? Well, we can say that it is a measure of how strong an atom attracts the electron in the bond. For example, let's take this example where here I have taken as a man and woman playing a tug of war. The rope be the electron. Well, man and woman let be the atom pulling the rope to the opposite sides. So if man pulls the rope to itself, so this means that the man is more electronegative than the woman. So coming to the basic concept and definition, we shall learn that electronegativity is a measure of tendency of an atom to attract a bonding pair of electrons. Or in other way, we can also say that it is a chemical property which describes the tendency of an atom to attract electron towards itself. So, it is also affected by two factors. First is atomic number, and second is the distance at which its valence electron resides from the charged nucleus. That is, higher the associated electronegativity number, the more an element or compound attracts electrons towards it. To know the concept, let's understand the concept. Well, we are discussing about the electronegativity bonding pair of electrons. So friends, as we discussed about the example which is like tug of war, where one pulls the rope stronger than the other, pulling the rope away from the other, or perhaps they both pull the rope equally or none of them is budging. So the two people representing two atoms, the rope is an electron, and the people who was able to pull the rope away from the other person represent more electronegative atom. So why and what happens to the atom who pulls the electron toward the sides or makes the electron be sharing? Well, we can also say that electronegativity makes the two atoms combine together in different ways. Let's find out. We basically call it bonding, or you can say a chemical bonding. So let's discuss what happens when two different electrons with two different atoms combine together in a different manner. Let's take two atoms A and B. Okay. Now first, what happens when they have same electronegativity? They obviously, no one can pull the electron towards their own side. So this is the A's and this is B's, right? So we have an equal sharing of electron between these two atoms. So what is the result? Well, if the atoms are equally electronegative, both have the same tendency to attract the bonding pair of electrons. So the bond which is formed, we call it a covalent bond, right? Where actually both these two atoms have same electronegativity. Okay. Now let's come to the second option. What if B having a slightly greater negativity than A. Okay, this is the A and this is B. So what happens to the electrons? Well, electron goes slightly towards the P. That is, the electron shifts towards the P. That means that P end of the bond has more than its fair sharing of electron, so becomes slightly negative. At the same time, A ends become slightly positive. So this is not exactly a mode of electronegativity. There's a slightly difference between the negativity of these two atoms. So we call it a polar covalent bond, right? As it is a covalent bond in which there is a separation of charges between one end and the other, or in other words, which one end is slightly positive and other is slightly negative. We can also give example like hydrochloride, where we have a hydrogen chlorine bond, or you can also say in water we have H2O, where we have slightly negative and positive bonds between the hydrogen and oxygen. So we call them a polar covalent bonds. Now, what happens to the third option, where P is actually having a more difference between the A, that is the electronegativity is very much higher than A, then obviously all the electrons will shift towards, that is the valence electron will shift towards the P and will form a ionic bond. So now friends, what do we conclude? How electronegativity helps to make different kind of bonding between one or more atoms? First, well, we have a pure covalent bond where there is a equal electronegativity, that is we have the very less polarity between the two atoms. We get a covalent bond when the electronegativity is approximately equal to each other. Secondly, when the electron have been dragged slightly towards the one end, we get a kind of a polar covalent bond. We get a covalent bond, but it is kind of a polar where we get two different charges onto the two different atoms, where there is a slightly changing of charges. Third, we get a ionic bond where the electronegativity, the atoms is high. That is the difference between the electronegativity of two or more atoms is high. We get an ionic bond. That is, we call it a purely ionic bond. For example, lithium iodide, on the other hand, will be described as an ionic bond with some of covalent character. So friends, we also conclude that no electronegativity difference between two atoms leads to pure non-covalent bonds, or a small electronegativity difference leads to a covalent bonds, as a large electronegativity difference leads to a ionic bond. So now friends, let's understand the related concept. We talk about now the elements. We always talk about two things, metals and non-metals, right? So when we talk about the metals, where the metals have a tendency to lose electrons and form the positive ions. So we call the metals as electropositive elements. On the other hand, when we talk about the non-metals, well, they have a tendency to accept the electrons and form a negative ion. So we always call the non-metals as the electronegative elements. So let's now understand the trend of the electronegativity in the periodic table. So when we talk about the groups, well, when we go down towards the bottom, that is when we move from top to bottom in a periodic table, or you can say in a particular group, the electronegative character of the element decreases. For example, when we go down in a group 17 of the halogen elements, the electronegative character decreases from fluorine to iodine. As out of fluorine, chlorine, and bromine and iodine, fluorine is the most electronegative element, whereas iodine is the least electronegative. Then we can explain why it has happened. So now, if we discuss about the electronegative character of elements in group, where I have taken the example of group 17, we call them the halogen group, where we have fluorine, chlorine, bromine, and iodine with the respective symbols. So, what happens? Well, when we go down in a group of the modern periodic table, one more electron shell is added to the atom at every step. So here, this is the nucleus, and these are the respective shells. We call it K, L, M, N, right? So when we move downwards, every step we get a new shell, right? So this means due to this, the size of atom goes on increasing. So what happen is, so when we go downwards, the size of atom goes on increasing respectively. So due to this increase in size of atom, its nucleus goes much more deep inside the atom, and the attraction of the nucleus for incoming electron decreases. Well, you can see the distance. When we go downwards, we keep on increasing with the shells, and the distance between the valence electron or the outermost shell electron and the nucleus, that is, which is having the positively charged particles, we call them proton. So attraction between the proton and the electron goes on decreasing when we go move downwards, and which actually makes the atom form a negative ion easily, because the electron which is less attracted towards the nucleus have much more tendency to get off from that atom. So from this discussion, we conclude that the tendency of an atom to gain electron decreases on going down in a group of a periodic table. So now I conclude like this: just because when we move downwards, the size of atom goes on increasing, and the attraction of the positively charged nucleus and the outermost shell electron goes on decreasing, so the electronegativity of the atom goes on decreasing. So here I conclude that the tendency of an atom to gain electron decreases on going down in a group. So friends, now let's understand what happens to the electronegative character in the period in the modern periodic table. Well, when we move from left to right in the period, the electronegative character of an element goes on increasing. As friends, when we move from left to right, we move from metals to non-metals. As we have discussed earlier, that metals are the most electropositive elements and the non-metals are the most electronegative elements. So by this concept also we can conclude that the electronegativity of the element from left to right goes on increasing. So to support this, I have taken an example of third period elements where we have like sodium, magnesium, aluminum, silicon, phosphorus, sulfur, and chlorine. So positively charged proton in the nucleus attracts the negatively charged electrons, as we have already discussed. And so as the number of proton in the nucleus increases, just due to the atomic number increases from left to right, the electronegative or attraction will increase. Therefore, the electronegativity increase from left to right in a row in the modern periodic table. As this effect only holds true for the rows in the period because the attraction between the charge falls off rapidly with the distance. So friends, let's understand why it happens by taking an example. So now we are discussing the electronegative character of the elements in the period, where we know that the electronegative character of the elements in period goes on increasing when we move from left to right. This can also be understood as when we move from metals to non-metals. So, to understand the concept, I have taken an example of period 3. So let's consider sodium, which is at the beginning of period 3, and chlorine at the end of this period. So let's think about this sodium chloride, the compound made from these two elements. Actually, it were covalently bounded to each other. So now let's understand Na and Cl. It is the sodium electron and this will be the chlorine electron, right? So what happens? Both sodium and chloride have their bonding electron in third level, right? The electron pair is screened from both nuclei by 1s, 2s, 2p electrons. Friends, the Electronic configuration you'll be learning in details in the higher standards. But to understand this concept, let's talk about these electrons that we have a slightly positively charged Na with the negatively charged Cl. So the electrons of these two will be shifting towards the chloride, making this that the ions are formed. Well, this makes the concept that the electronegativity increase across a period because the number of charges on the nucleus increases that attracts the bonding pair of electrons more strongly. As we have already made you understood why it happens, let's conclude this session. We have already discussed that the positively charged proton in nucleus attract the negatively charged electron, right? So when we move from right to left, what happens? First, the number of proton in nucleus increases. That means the atomic number increases. Consequently, what happens? The attraction of the electron increases. So the tendency of the atom to attract the electron for bonding increases. Hence, we say that the electronegative character of the element increases. Yes, when we move from right to left. So now let's conclude the concept. As we know that positively charged protons in the nucleus attracts, which certainly means that the electronegative character will increase. So this affects hold true for rows in the periodic table because the attraction between the charge falls rapidly with the distance. Well, when we move from sodium to chloride, the graph goes like this. Sodium, magnesium, ammonium, silicon, phosphorus, sulfur, and chlorine. So the graph goes like this when we talk about the electronegative character. So friends, this means that the attraction that a bonding pair of electron feels for a particular nucleus depends upon the number of protons in the nucleus, the distance from the nucleus, and the amount of the screening by the inner electrons. As we have already discussed that the electronegativity increases across the period because the number of charge on the nucleus increases that attracts the bonding pair of electron more strongly. So now let's understand the electronegative relationship in the modern periodic table with respect to the diagonal trends. Well, at the beginning of period 2 and 3 of the periodic table, there are several cases where the element at the top of the one group has some similarities with an element in the next group. Let's take some examples and notice the similarity and dissimilarity between the negativity, that is the electronegativity character of these elements. For example, boron is non-metal with sub-properties rather like silicon, while the rest of group 2 beryllium has some properties resembling to the aluminum, and lithium has some properties which are differ from other elements in group 1. So in some way they resembles to magnesium also. So it is said that the diagonal relationship between these elements, there are several reasons for this, but each depends on the way atomic property like electronegativity varies around the periodic table. So we will have a quick look that with regards to the electronegative, which is probably the simplest to explain. For example, we have the electronegativity of beryllium and boron, which have, let's discuss and write. So taking one example, boron, the electronegativity as 2.0 and aluminum with 1.5, where the electronegativity falls as you go down in the periodic table. So the boron and aluminum have these kind of respective electronegativity. So comparing the beryllium, which is 1.5, and aluminum, we'll find that they're exactly same, as the increase from group 2 to group 3 is offset by fall as you go down group 3 from boron to aluminum. Something similar happens from lithium to magnesium also, or from boron to silicon. So in these cases, the electronegativity are not exact the same, but are very close to each other. Or similar electronegativity between the members of these diagonal pairs means that they are likely to form similar type of bonds, and that will affect the chemistry of these elements. So by this, we come across the example of these kind of elements with the diagonal relationship with the having the same kind of that is very close electronegativity character, which makes the similar kind of bonding. So students with who's having the future career in the chemistry should go through in the higher standards about the bonding and the electronegativity relationship. So here I end up with my session of my electronegativity concept and the trends in the modern periodic table. I hope you have understood this session. So in next session, we shall discuss the advantages of the modern periodic table. Thanks for watching Edupedia World videos.